In problem 1-5-6, we are given the rate of heat loss, which we must divide by 2 because there are 2 samples. Then we are able to use the equation stated, and we are solving for thermal conductivity. We are given all necessary information to plug in and solve for K. As just seen in the work below, we are able to use the surface area, AS, and plug that in as shown on the right in order to determine a K value of 0.781. In the second problem, we are using Newton's law of cooling. We are given a convection heat transfer coefficient, which we can then plug in for H, use the surface area and temperatures provided to solve for a Q value of 289,027 BTU per hour. For the second part, we would like to determine the annual cost of this energy loss. Here we are able to use that Q is equal to Q dot delta T, which we are given that information, and determine the annual energy loss by using the conversion factor given and determining that it is $1.10 per therm, which we are then able to get a value of $32,384 per year. In 1-78, we're using our knowledge of the Q absorbed and Q emitted equations. Here we are asked to set them equal and solve for the temperature, as the surface temperature of the spacecraft is asked when the radiation emitted equals the solar energy absorbed. Here we are able to solve for the T, the areas cancels, they are the same, and we are able to get a T value of 281.54 Kelvin. For 14-24, we will be using our information on binary diffusion coefficients. For part A, we are able to just use the table, as it is at 200 Kelvin and 1 atm. Now we are able to relate a change in temperature and pressures using the ratios on the right in order to determine the following binary diffusion coefficients for B and C. This is used for the relationship that we were taught in class for T to the 3/2 divided by P, or the second relation used there, which is what was used in this problem. The points of confusion I have at the end of this week is the binary diffusion coefficients. I would still like to work with them some more and understand the ratio a little bit more. In addition, I am still a little concerned and confused with the difference between convection and conduction. I believe that I have a basic understanding, but I plan to work on these topics more.